you a few minutes to read it. Well, let me zoom out, try to get it. So, and nobody will ask you to memorize any equations, but we need to do our best to know exactly where are the equations needed for a problem like this. Here it is. Problem number 2. Problem number 1, we solve it, the mass diagram problem. I will scan it, send it to you, or somebody on Monday will do that. So I said an overhead sign is located at the BVI station of a crest vertical curve. The grades are 3% positive and negative 2%, with a vertical curve length of 500 feet. The BVI of the curve is at station 85 plus 00 with an elevation of 202.3. In order to provide a clearance 16 feet, the minimum elevation of the bottom of the sign is most nearly. You see that? Again, equations, they are available. So this is a crest vertical curve. This is a vertex, or the BVI, by the way, point of vertical intersection, BVI. And this is the beginning of the curve. And this is the end of the vertical curve, EVC. And this is L, as all of you know that the curve length is measured horizontally. So L, he said that it is 500 feet. And we have a sign, the BVI first of all. Let me put the information about the vertex. It is at station 85 plus 00. And the elevation here is 202.30. And somebody put a sign here at this station. Somebody passed his PE and he is happy. And he said that just passed PE. He just passed his PE exam, so big sign. We need from here to here, this is a sign. We need a vertical clearance minimum of 16 feet. So what is the elevation of the bottom of the sign? So the elevation of the bottom of the sign, this is what he's looking for. Knowing the station and the elevation of the vertex. This is a vertex here, or the BVI. Do you see the picture? Okay, while you are studying, try to draw as much as you can. Translate as much as you can, because this will make your life easy during the exam. You don't have to draw every single problem during the exam, because by practicing during the preparation, you will be able to visualize or look. Okay, so we need the elevation to be, we need the elevation here. The grades are given, by the way. This is plus 3%, and this is minus 2%, which is G1 and G2. Do you remember G1? And this is G2. The grades are given, the entering grade and the exiting grade, and the curve length. So this station is given, which is a BVI, where the sign is. There are more than one way to solve the problem. And this is true for some problems, by the way. Some problems, there are more than one way. And always ask yourself after you solve a problem, is this the only way to solve this problem? Maybe there is another way, shortcut. Maybe there is another shortcut, faster, time saving. If you look to my book or any other surveying books, you will find this distance from here to here, it has a name. The distance between the curve and the vertex. I call it in my book D sub O, or we call it E. Actually, they call it E. So D sub O or E, we call it offset or vertical offset, vertical offset at the BVI. So if you have any surveying book, including mine, I didn't invent surveying. I'm just presenting surveying. Do we have an equation for D sub O or E? You will find there is one equation. It says that it is AL divided by 800. D sub O or E. So if you plug the numbers, A is the algebraic difference, by the way. A is the algebraic difference, G2 minus G1. So A is 2 and 3 is 5, or minus, so it is 5 times 500 over 800 will give you a number. This number is, and I know you have some questions, this will give you 3.125 feet, if my math is correct. First of all, locate the equation in my book, in chapter 10, by the way. Chapter 10, at the end of chapter 10 of my textbook, you'll find this equation there. Since I know this distance from here to here is 3.25, so, and I know the total distance to be 16, that means that the remaining is what? The remaining distance between the BVI and the bottom of the sign is equal what? Is equal the difference, 16 feet minus 3.125 feet. So if I know from here to here is 3 D sub O, and I know from the curve to the bottom of the sign 16. This is where the traffic will be. So the difference between them is 16 enter 3.125 minus, it is 12.875 feet. Since I know that, and I know the elevation of the BVI, so the elevation at the bottom of the sign is equal what? Is equal the elevation 202 that's given to me 0.30 plus the 12.875. So if you do that, 202.30 plus, I get 215.175 feet. And this will give me 215, the closest 1.18, and the answer is B as in boy. Any question about this? This is one way. There is another way that you can determine the elevation along the curve itself at this point using the general equation. You can use this general equation, y is equal at any distance x is equal y of the BVC plus g1x plus rx squared divided by 2, which is a general equation for vertical curves. And after that, I will add the 16 feet to it. But what I did, I calculated E, or the D sub O, and I took the difference, I add the difference to the elevation of this point. But this one is a little bit longer, a little bit. Is not the other approach, calculating the elevation along the point, or at the point along the curve, and add 16 feet to it. This is another way. But this is shorter as far as the way to solve it, and you are very welcome to solve it the other way. Will be a good test for you or a good practice for you. Makes sense?